Alrighty. So if you're watching this video, you already saw the directions. Just capping those off. Right, the decoration, that's up to you. This is for you to be creative as possible. All right. And turn the crank, watch your creation move. Create different effects by placing the bottom circle in different locations. All right. That's true. If you were to slide the cardboard circle to kind of one side of what we call the guide circle. All right, so you've got the follower, which is that bamboo skewer in the top. On the bottom of it is the guide, all right, which is that other cardboard circle. And then your cam is the cardboard circle that's going this direction and turning. If you move it to the side, what happens? All right, if it's right in the middle, what happens? You might see some differences in the action of your toy. So we'll go through the fine points here. To make sure your skewers line up, I think we have taken care of that for you when I created those holes. So that should be fine. To build a model that moves up and down without turning, so they mean without spinning, place the skewer through the bottom circle off center. When turning the crank, make sure the bottom circle touches the very middle of the top circle. Okay? So this is to kind of getting back to what happens here. This is to ensure that your decoration on top does not spin. All right. However, this says to move or build a model that moves up and down and turns around or spins around, place the skewer through the bottom circle off center. All right, like I was saying earlier, and have the bottom circle touch near the edge of the top circle. Okay, instead of right in the middle, it's to the side when turning the crank. All right, so that should not only give you some up and down motion, hopefully, but some spinning motion. All right, so concepts involved. The wheel and axle is a simple machine that can act as a lever to provide mechanical advantage. A crank allows you to turn a wheel and or axle by providing a force at a distance from the center. Right, so think about it. Not only is it literally easier to crank if you create that handle for your wheel and axle system, but for those of you studying simple machines with me, you'll know that if you were just trying to spin the skewer with your fingers, that actually takes more effort force than if you create a crank that's really big, right? Which would require less effort force. All right, that's something we call mechanical advantage. Okay, so talk to me about that if you have questions. But yeah, it's an interesting concept. Cranks can convert circular movement into up and down reciprocating motion. All right, so that's what we were talking about. You take rotational movement, all right, of the spinning of the crank, and it converts it into linear motion up and down. All right, pretty cool. Forces applied to the edges of wheels can result in a mechanical advantage. That term I just used, which is the multiplication of the original force applied. Likewise, forces applied to the shaft of a wheel can create an advantage of distance, which means you may have to provide a larger force, but the resulting motion is over a larger distance. Okay, yeah, that's kind of the concept of simple machines. All right, and with an example of a simple machine like a lever, right, we know that this is your lever and your fulcrum's right here. Or let's put the fulcrum over here, and this is you. All right. If you have the fulcrum way over here and you sit down on this, you could lift a really heavy person, right? Someone much heavier than you. All right, because of this extra distance between you and the fulcrum. All right. On the opposite side, right, if you were here and you were trying to lift a really heavy person, you aren't going to do it. All right. Unless, yeah, you create more force somehow or throw sandbags on or something like that. So that's kind of what it means by mechanical advantage being a trade-off between distance and force. Our focus questions. I think we might spend some time going through these as a class. So at this point, I'll end this video.